At 11:47 on the morning of September 15, 1977, Chief Nuclear Operator William J. Morrison stood in the control room of Pickering Unit 1, 40 kilometers east of Toronto, watching reactor power climb toward 2,160 megawatts thermal. 43 years old, 17 years with Ontario Hydro. He was supervising the startup of Canada's first commercial nuclear power reactor, a CANDU design that would either prove Ontario could master atomic energy or become the most expensive engineering failure in Canadian history. The control panel displayed readings that made conventional power engineers nervous. Neutron flux approaching 100%. Heavy water coolant at 310 degrees Celsius. Reactor core containing 4,560 fuel bundles of natural uranium. Pressure tubes holding 12.4 megapascals. Enough force to rupture steel if containment failed. Ontario had bet $780 million that CANDU technology, Canada Deuterium Uranium Reactors designed by Atomic Energy of Canada Limited, could provide baseload power without the enriched uranium required by American light water reactors. If Pickering Unit 1 worked, Ontario would build more. If it failed, the province would return to coal and oil, while electricity demand doubled every decade. Morrison gave the command to continue the startup sequence. Neutron flux stabilized. Steam generators produced 540-degree superheated steam. Turbines spun at 1,800 RPM. The generator synchronized with Ontario's grid. Pickering Unit 1 produced its first commercial electricity at 12:03 p.m., 542 megawatts. The reactor worked. The problem began in the 1960s when Ontario discovered its electricity consumption was growing faster than new generating capacity could be built. The province depended primarily on hydroelectric power from Niagara Falls and northern rivers, but suitable hydro sites were largely developed. Coal plants provided backup, but coal had to be imported from the United States and created air pollution. Nuclear power offered an alternative. A single CANDU reactor could produce 540 megawatts continuously, equivalent to a large coal plant, but without air emissions or fuel transportation costs. The reactor core was compact, roughly the size of a house, compared to a coal plant requiring acres of boilers and pollution control equipment. But nuclear power carried risks that coal didn't. Radioactive fuel, high-pressure coolant systems, the possibility, however remote, of core damage releasing radiation. Ontario Hydro Chairman Robert H. Saunders made the decision in 1964 to proceed with nuclear development. The province would build 4 CANDU reactors at Pickering, east of Toronto, where Lake Ontario could provide cooling water. If successful, more stations would follow. Chief Project Engineer Harold Smith, 51 years old, veteran of hydroelectric construction, took charge in 1966. Smith had built dams and powerhouses, but nuclear reactors required different expertise. Precision welding of pressure tubes, radiation shielding calculations, fuel handling systems that prevented human contact with radioactive material. Construction began in 1968. Workers excavated 18 meters down to bedrock, then poured concrete foundations 4 meters thick. The reactor building, a reinforced concrete structure with walls 1.2 meters thick, was designed to contain any radioactive release. The containment could withstand internal pressure of 140 kilopascals and external tornado winds of 480 kilometers per hour. The reactor core itself was unique to CANDU design. Unlike American reactors that used a single large pressure vessel, CANDU employed 390 individual pressure tubes, each containing 12 fuel bundles, arranged horizontally through a calandria tank filled with heavy water moderator. This design allowed online refueling, replacing fuel bundles while the reactor operated, eliminating shutdown periods required by American reactors. Installation of the pressure tubes required extraordinary precision. Each tube, 103 millimeters in diameter and 6 meters long, had to be aligned within tolerances of 1 millimeter and welded to inlet and outlet headers that circulated pressurized heavy water coolant. A single defective weld could cause tube rupture during operation. Chief Welding Supervisor James Patterson, 38 years old, certified nuclear welder, personally inspected every pressure tube weld. He rejected 47 welds that passed initial inspection, but showed minor defects under X-ray examination. Patterson's team spent 11 months installing and verifying all 390 pressure tubes. Pickering Unit 1 achieved criticality, the point where nuclear chain reaction becomes self-sustaining, on February 25, 1971. Neutron detectors confirmed that uranium fuel was fissioning, releasing heat. Over the next 6 months, operators gradually increased power, verifying the control systems maintained stable operation. If you want to see how Ontario built the largest nuclear generating fleet in North America through a technology nobody had proven at commercial scale, please hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to Ontario's nuclear program. Pickering Units 1 through 4 came online between 1971 and 1973, providing 2,160 megawatts combined. The success convinced Ontario Hydro to proceed with a second station. Bruce Nuclear Generating Station, located on Lake Huron, 300 kilometers northwest of Toronto, would be larger. 8 reactors, each producing 750 megawatts. Total capacity, 6,000 megawatts. Bruce was designed for scale. The station would house 8 reactors in 4 connected buildings, these sharing support systems and operating staff. Construction began in 1970. Bruce Unit 1 came online in September 1977. The remaining 7 units were completed by 1987. But nuclear expansion created a new problem: radioactive waste. Each CANDU reactor produced approximately 90 tons of spent fuel annually. Fuel bundles containing fission products that remained radioactive for thousands of years. Ontario Hydro built dry storage facilities at each station, placing spent fuel bundles in concrete containers that would contain radiation for centuries. The third station, Darlington Nuclear Generating Station, east of Toronto, incorporated lessons from Pickering and Bruce. 4 reactors, each producing 881 megawatts. Advanced containment systems, improved emergency core cooling. Construction began in 1981. The first unit came online in 1990. By 1993, Ontario operated 18 CANDU reactors at 3 stations. Bruce, 8 units, Pickering, 8 units, and Darlington, 4 units. Combined capacity, 13,000 megawatts, approximately 60% of Ontario's electricity supply. The nuclear fleet had transformed Ontario's grid. Electricity rates remained stable despite rising coal prices. Air quality improved as coal plants were phased out. The Greater Toronto Area, growing towards 6 million people, had reliable baseload power. Today, Ontario's nuclear fleet continues operating, though aging infrastructure requires constant attention. Pickering Units 2 and 3 were permanently shut down after pressure tube degradation made operation uneconomical. Bruce Units 1 and 2 underwent complete refurbishment between 2005 and 2012, replacing major components, including reactor cores. Darlington is currently undergoing refurbishment that will extend operations to 2055. But the fundamental vulnerability remains. Ontario's economy depends on 13,000 megawatts of nuclear generation functioning normally. A simultaneous loss of the nuclear fleet, whether from a severe seismic event affecting all stations, coordinated cyber attacks on control systems, or emergency shutdowns triggered by external grid instability, would create an immediate 13-gigawatt deficit. Ontario maintains interconnections with neighboring jurisdictions that can import approximately 3,000 megawatts. Losing 13,000 megawatts exceeds import capacity by more than 4 times. Grid operators would implement emergency load shedding within minutes, deliberately cutting power to industrial customers and rotating blackouts through residential areas. The Greater Toronto Area would experience rolling blackouts affecting 6 million people. Industrial facilities, steel mills, auto plants, chemical factories would shut down. Hospitals would operate on emergency generators. Water treatment plants would switch to backup power. The economic impact would exceed $1.5 billion per week. Unlike other generating sources that can be brought online gradually, nuclear reactors require days to restart after emergency shutdown. If all 18 reactors scrammed simultaneously, restoration would require 2 to 5 days per unit, assuming no equipment damage occurred during the shutdown. The system has no redundancy beyond the 3 geographically separated stations. It operates continuously, trusting that reactor systems function correctly. Cooling water remains available, and electrical grids remain stable enough to remove generated power. William J. Morrison continued working at Pickering until his retirement in 1997. He died in 2014 at age 80. The control room procedures he established for CANDU startup remain standard across Ontario's nuclear fleet. Harold Smith retired from Ontario Hydro in 1983 after overseeing construction of Pickering and early Bruce development. He died in 2001, age 86. The precision construction standards he demanded, particularly for pressure tube installation, prevented numerous potential failures. James Patterson continued as chief welding inspector through Bruce construction, personally supervising pressure tube welding at all 3 stations. He retired in 1991 and died in 2019, age 87. Not a single pressure tube he certified has failed during operation. Ontario's nuclear fleet operates 24 hours per day, 365 days per year. Control room operators at each station monitor neutron flux, coolant temperature, and reactor power. Heavy water coolant circulates through pressure tubes at 7,000 kilograms per second. Steam drives turbines generating enough electricity to power 13 million homes. And somewhere in the reactor cores at Bruce, Pickering, and Darlington, uranium atoms are splitting, releasing neutrons that strike other atoms, maintaining the chain reaction that has powered Ontario continuously since September 15, 1977. When William Morrison watched Pickering Unit 1 synchronize with the grid. The system continues. Ontario depends on it continuing. If this story moved you the way it moved us, do me a favor. Hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about infrastructure that powers modern civilization. Real people, real engineering, real stakes. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer. You're part of keeping these memories alive. Tell us your location. Tell us if you've worked in nuclear power or electrical systems. Just let us know you're here. Thank you for watching. And thank you for making sure William Morrison, Harold Smith, and the engineers who built Ontario's nuclear fleet don't disappear into silence.